A lot of DC modelers are now seeing the advantage of reducing the wiring from the point control board to the points to just 2 wires, instead of a bundle of wires to each point motor. This is done by creating an accessory bus serving, in this example, Cobalt IP digital point motors. Originally to provide an input for a computer-based system sniffer port, hence the name, the sniffer can also create a low-cost accessory bus system separate from the DC, AC or DCC system that operates the locos. The Alpha Central is a plug-and-play point controller with LED buttons. We say point controller, but of course it can control any digital accessory. Having converted its commands into a digital signal, it sends these digital commands into the DCC system, in this case using a sniffer. Cobalt IP digital point motors are supplied already centered. This is to aid centering the point motor underneath the point's tie bar like this, with the tie bar in the central position like this. Once given a command, they move to one side, ready to operate. However, early models were supplied with self-centering enabled and need to be allocated a special address of 198 to remove self-centering. Using, for example, this NCE power cab, the address is formed like this. Gently slide the set run switch away from the body of the Cobalt to set. Now slide the switch to run. Switch off power to the Cobalt for a few seconds, then on again. The dilemma for DC modelers was that creating an address of 198 without a DCC handset is not obvious. The purpose of this video is to describe a procedure to cancel self-centering mode, i.e. disengage the Cobalt IP digital from self-centering every time it is powered up. To do this, we must make the Alpha Central readdress the point motor with the address 198. The default addresses of Alpha Centrals are 1 to 12. However, the first address of this sequence can be changed manually. Switch off the power to the Alpha Central. Using this switch is best. Press down ACC, then switch it on. And the next procedure is similar to setting a digital clock. Pressing the cab button cycles through the 4 digits that are in turn changed using the ACC button. To make 198, we leave digit 1 as 0, press cab, digit 2 to 1, cab, digit 3 to 9, cab, digit 4 to 8. The next bit is cute. Press down cab until the display reads yes. If you think you've made a hash of it, just don't press cab. Turn it off then on and it will be as if you never touched it. Then try again. So, the first address number is now 198. This is confirmed when selecting the point, as 198 will flash up on the display. Gently slide the set run switch away from the body of the Cobalt point to set. Now slide the switch to run. Switch off power to the Cobalt for a few seconds, then on again. Switching off at the mains might not work, so remove a wire at the point or at the accessory bus input. Nothing happens, but don't fret. The point will move the next time it receives a normal command. So now we need to restore the original address sequence on the Alpha Central. Press ACC, then switch on. Cab, then ACC to change to 0. Cab, then ACC to change this one to 0. Cab, then ACC to change to 1. Press and hold cab for yes. Assuming it is a new point motor, it will have a default address of 1, so selecting the first input will now move the motor where it will now stay in its chosen position, left or right. Well, that's how Cobalt IP digitals have centering removed. Now you've achieved this, if for example you are reusing the Cobalt on a new point, you can use the same procedure to center it again, but this time use address 199. If you want to reverse the throw of your Cobalt IP digital, doing the same will do it, but this time with a temporary address of 197. While we're on the subject, Cobalts never forget their original address during this 197, 198 or 199 procedure, so they will just revert to whatever address it had before the procedure. Don't forget to visit our website dccconcepts.com for other tips, as well as other videos that help you set up, operate and, most importantly, enjoy your layout.